Hi there, this is John from REVsoft, and this presentation is a quick overview of multi-run for regular and group jobs in REV Scheduler version Enterprise 10.3. This applies to all platforms. Okay, let's go. Multi-run jobs can be executed in two ways. The first way that we call is a regular way. This is the same delay between executions bounded by a start time, and it will end by end time or number of executions. This is where you see the green recycle image. So we can set a multi-run job to start at 4 o'clock and have 15-minute delay between start times. Then if we use the end time, it'll be bounded by 4 o'clock, 5 o'clock, 15-minute delay, so it will execute those times. If its end is by executions, it will start at 4 o'clock and do 4 executions. So that's a green recycle image using a regular delay. The second way is a preset. This is where you set the times for the executions after the start time. This is a blue recycle image. So you don't have to register the start time because that's the start time of the job at 4 o'clock. You register every initial execution after that time. The sequence number here to register the executions is a 4-long decimal field, so it will more than cater for the 1,440 minutes in a day. Okay, so we've got the green and the blue. Is there anything else? Yeah, well, there can be a curveball in there too. On the IBM I series, there are 2 job variations for both of the multi-run types. This is the way the jobs are executed on the I series. Stay active is this job will stay active and it will delay between executions. This is a green dot with in the middle of the image for either of the regular or preset times. The reason we have a job like that is it will execute on time every time. It uses a delay wait between executions, which uses 0 CPU percentage on the I series, but it will block one subsystem slot for that job as it's staying active. The second mechanism is it will submit the job each time for execution. So this is a blue dot in the middle of the recycle images. If we're on non-IBM I series, so AIX, Linux, Unix, Windows, there's only one type where it cannot submit each time. So it will stay active all the time. So on non-I series platforms, you will only see the green dot there each time. The blue dot is unique to the I series, and this is the same whether it's a regular job or child jobs within groups, which can be local child jobs or remote group jobs on networked servers. Okay, one question we commonly get is what happens when an execution runs over the time for the next execution. Now, to display this, what we did is we set up jobs on an IBM I series that starts at 10:20 and executes every 2 minutes with the last execution at 11 o'clock. So what we did then is we created a script that will do a delay job for 3 minutes, which will exceed the 2-minute delay time. And then we set up a preset job on the I series that would run at different times there, and we created a delay job that would run for 3 minutes, which would then overrun those times. Okay, so here's those 2 jobs. Here we've got JM test overrun, which is green. As we know, that's a regular cycle between them with the delay time. And we've got the blue one here. Right, let's look at the green one first. Here we go, 10:20, 2 minutes, and 11 o'clock finish. And if we look at the script on there, it's a delay job of 3 minutes. Now if we go to the preset one, what we'll see there, it's going to start at 10:20, and here are the preset times that we've got defined for it. All set there, and the same way, let's go to the script there, and it's the same one, delay 3 minutes. Okay, so that's the definition there, and as you can see, we've got green and blue ones, and we set up all 4 possible versions of that so we can see how that runs. So let's see what happened when it executed. Okay, here's the operations, and let's just filter on over. Here's the first one that ran, the regular one with the stay active, and as we can see, 21 of 21 executions have been done. Preset 1, 10 of 10. Okay, here we go. Here are all the executions for that job, and if you want to just see a summary of how the status was, there they are. 10 bypassed execution, 11 actually executed. Now we can see here the first job started at 10:20, ended at 10:23. Took 3 minutes, then a lot of different microseconds there, and it was due to go the next one at 10:22. Because it's finished at 10:23, that was skipped. So that's what the bypass execution looks like with the regular run. Now let's look at the preset one where we had different times, and what you'll do is you'll see it all in a similar fashion there, where you can see the start time, end time is 10:23, so 10:21 and 10:22 would have been skipped. 10:24 is the next execution. So this is what will happen if a job runs longer than it should. The next ones will be bypassed, but then it goes back to the normal cycles of the times you have defined for each of the instances to run. Okay, so now let's get into group job land for multi-runs. Now this executes in the same fashion no matter whether the group child jobs are on the local server or on network servers. Let's take a look at the local child jobs first. We set up a regular job on an IBM iSeries that started at 6:45, executes every 15 minutes, and the last execution is 8:30. So 7 executions. The group and all the local child jobs run in a sequential manner. And then we set up a preset job on the IBM iSeries that would run at those 6 times. And these are also executed in a sequential manner. So let's see what that looks like. Okay, so back into the scheduler definitions, and let's change the filter this time to MLAN. And what we'll see here is they both submit each time with the blue dot in the middle, regular and preset. So what we can do is let's take a quick look at the job. First one there, which is a regular interval job. Let's take a quick look at that and see how it's going to execute. Now we can see here it's going to execute at 6:45, 15 minutes, go to 8:30. And if we check the group jobs, they're all local because they're done on the local server. And some people will ask, why does it say local there, star local? That's because if you've got it replicated in a high availability environment, it will work on the local server. You don't have to name the server in there. So that's done for HA purposes. That is another presentation in there. We'll see that they're all waiting for each other by the sequential dependencies there. So that is a regular interval. Here is the preset one, and that is going to start at 13:45, and its number of executions we'll see in here are 6 there, and here we have the executions for that one. The group job structure is exactly the same, all sequential. And anyone that's new to group jobs, there are no scripts there because a group parent's job is to look after the child or children, in this case, whether they be local or on network jobs. Okay, that's what the definition looks like. Let's see how it ran. Okay, back to scheduler operations, where everything is pushed to this desktop here, changes colors, plays sounds as it's running, all those type of cool things. Now, let's just see the executions first. Okay, this all executed fine. No problems at all. Duration was 8 minutes, but the difference between executions was 15 minutes. The group jobs, how did they execute? Here they all are here. All fine with all the different timing mechanisms down to millionths of seconds. Yeah, that looks fine. Let's check the preset one. Again, with the times between the intervals, it was long enough that each of them could run. In a similar fashion, I can drill into all the child jobs that ran within the group structure with all the timing mechanisms in there down to millionths of seconds. Okay, so that's group multi-runs on the local one. That's cool. Alright, let's move on to now group multi-run jobs with network jobs. First of all, let's just take a quick look at the images here. All the blue ones mean these are local jobs. When it's got a blue person and a view person, because view is a multicolors, that tells you that this is working in a network. That's exactly the same for group jobs and dependencies. If you see dependencies where it has a different colored person here, that means they're network dependencies as well. So just again, what you'll see is a different colored in the image there. So if we go on to check out some of these, multi-X, here we go. We've got the jobs here. The one we're going to look at is multi-X mix. So that job there is a regular one that will submit each time because it's a green recycle image with the blue dot. So what we've got there, again, it's going to start at 8:55, have a 5-minute gap, and end at 9:30. Now the child job situation here is a little bit different to what we saw before. First of all, the parent job will start. The first child job is on a Windows server. It will then submit another one on a different iSeries server, so another remote iSeries server. Then it will wait, and when those two have completed, it will submit a job on an Oracle Linux server, submit a job on an AIX server, come back, and when those two have completed as required here by the completion status, it will then submit a job on the local server. Now this is the same group structure we've got in the preset times, but let's just check the preset times. So mix_P is a preset one, and what we'll see there, its preset times are set there. The group structure though is exactly the same. We copied the same group structure across to that one. Okay, so now we've got our definitions for our multi-run on networked group servers. Let's see how it executed. Okay, let's start with our friend here, multi-X mix. Let's look at the multi-run times. Whoa, hang on, one of them didn't execute. It had a 5-minute delay between executions, and one of those executions took longer than 5 minutes, so one was skipped. So what we can do is we can drill into the remote jobs for the group job structure, see how long they all took, again down to milliseconds. Now don't be concerned if some of the times don't exactly match what they are here, because the entry start end time are all times from that remote server. They aren't this local server time here, they are the times they executed on the remote server. So if you executed on a job on a server, say in the UK, Asia, any other place, it would have the times it executed on that server, those server times. So these are the remote server times. But what we can see, it goes 1, 2, 4 there. So cycle 3 was skipped, as we can see here, because it ran longer than the 5 minutes. Okay, well now what I've done now is filter the view further down so we can just see the preset times one. So if we check the preset times, they all look fine. That's executed fine each time. So we do have the differences between the cycle times for the regular ones and the multi-run with the preset times. Now what we've done is we've probably allowed there the preset times to be long enough between executions that those jobs on those other servers have had plenty enough time to execute. As you can see, the durations here is less than 5 minutes each time, even though the cycle times here are 10 minutes, 15 minutes, 10 minutes, 20 minutes, 15 minutes. Okay, so we've covered all the network jobs here as well. So just summing up, there's two different types of manners for the group jobs. There's a regular cycle, the preset times. Then on the IBM iSeries, it can either stay active, which will use one subsystem slot, or it can submit each time. And then the multi-run group jobs can either be running on your local server or any network server running REV Scheduler and RevView. If you've got any questions, please send them through to product_info@revsoft.com. Thank you very much for your time.